Great.
Namaste. I'm Bindu Srivastav from Telecommunication Standards Development Society, India. And welcome to the first webinar on the TSDSI Expert Talks. TSDSI, as you might know, is India's telecom STO, and we've recently made waves. Our radio interface technology has just got accepted at ITU as one of the INT technologies. So apart from that, our vision is to promote Indian digital communication standards to drive domestic economic and policy activities and enhance India's competitiveness for ICT goods and services in global markets. We collaborate with global forums and STOs so that there is early alignment on standards and Indian requirements and solutions get reflected in the global standards. As we reach the cusp of deployment of 5G, there are lots of new technologies that are coming up. So we thought the Expert Talks, we should launch a series called Expert Talks, where we engage with experts who will talk about technologies for the future. So here we are with the inaugural talk by Professor Arogyaswami, the father of MIMO, and he doesn't need any introduction, but still many of us know him as the father of MIMO and the person who pioneered MIMO OFDMA. But some of you may not know that he was also he was instrumental in driving one of the key projects in the Navy in the late 70s on APSO sonar. He was also decorated with the Ati Vishisht Seva Medal in 1983 and in 2010 with the Padma Bhushan. He's also received several awards globally. Professor Paulraj will be talking about progress of 5G, and he will also give us a sneak peek into 6G. This talk will be moderated by Professor Uday Desai. Professor Desai has been the founding director of IIT Hyderabad, and he's still there with them as the Professor Emeritus. He consults and is on the advisory board of several academic institutions in India and abroad. He's also currently the Chancellor at Anurag University, Hyderabad. So without much ado, I would hand over to Professor Desai and request him to start with the webinar. Thank you.
Thank you, Bindu. And at the outset, I would like to thank Professor Paulraj for this particular expert talk. I think we could not have launched this whole webinar series with anybody better than Professor Paulraj. And particularly, it's probably 5:30 a.m. in Palo Alto, and I think he's gotten up very early for our webinar. A special thanks to him. He has always been accommodating. Whenever we call on him, I think he's always there. And to mention about the LMLC, which has now been accepted by ITU, in fact, he has been also a guiding spirit in the development of LMLC. Because he has been guiding the wireless communication technologies in India for almost, I would say, the last 2 decades. I remember when I was at IIT Madras, he used to come and kind of spend time with the Tenet group and advise them on the ways to go. So I think a lot of hard work that he has also put in. He's as I say, many people are kind of known because they did the work. Okay, but here, when you do look at the work, you think of Paulraj. So when you look at MIMO, it is Paulraj. It's the other way around in his case. Okay, and also he has been involved in guiding India and interacts with many government bodies, in India. Okay, at the highest level. Also across the globe, I think he's been consulted by European unions, by various other government, American government, for advice on future of wireless communication and a lot of issues. So it's really, without spending a lot more time on this, let me say that, it is my great pleasure, ladies and gentlemen, to introduce to you a very proud son of India, Professor Arogyaswami Paulraj. Paul, I'm handing over to you. Thank you so much.
Thank you, Uday. It's nice I'm really pleased to join this webinar this evening. Let me begin by congratulating TSDSI. I think it's done a great job. It's been around for 3 years, grown very rapidly, and certainly recently a major win by getting an RIT approved by the ITU. And I see in terms of their documentation, in terms of their white papers, their efforts within ITU, they've done a wonderful job. So congratulations. My own, I don't go much by academic research, but my own interaction with the industry is now a little old in terms of the fact that last time I was building chips or systems was 10 years ago. So there's a long time away. But I've been active on company boards and venture capital, mainly US, a little bit in Israel, and some of them are in 5G. So my perspectives come from those interactions. So, Uday, you want to ask me questions? How do you want to, shall I say a few words about 5G? You're muted. Uday, I can't hear you.
Yeah, I would say that you go ahead. You had a few slides also. So some of the
sure.
few things you can display. So maybe you can talk for about maybe 25, 30 minutes and give your overall perspective.
Okay.
Then we can get into Q&A.
Okay. Then let me share the, we should be able to find it. Okay.
Yeah, I think it's coming up. I don't know why this other screen is on. Right? Two screens.
I'll have to go back and then do application window.
Okay.
Okay. Can you?
Yes, we can see it. Yeah, you can go to presentation mode. So people, perfect. Yeah. Perfect.
Okay. So I think everybody here doesn't need to see this slide, but just for anybody who's not in wireless. So 5G is really the latest avatar of 2G and 3G and 4G, and 2G started out with basic phone, and 3G gave a little feature phones, a little more speed on data, and 4G was really the broadband data and smartphones. And we've been India, I think, really began to grow its network around late 1990s or early 2000, and now 4 years ago we launched 4G, and 5G is the next one on the horizon. But 5G is much more than another G, because 2, 3, and 4G were all about phones. 5G is about phones, certainly, but a lot more applications. And therefore, it's both evolutionary of another G, but also much more than that. Lots of new revolutionary services. And for this reason, it's making a tremendous splash. It is seen by every country as critical infrastructure for its growth, and sometimes called transformational. So it is really an inflection point, and therefore great opportunity for India. So a little bit about applications. Again, this is a picture that most of you have seen. So 5G sort of horizontally can be seen as three core ideas. One is extreme mobile broadband, and that's essentially getting higher speeds on the link, and that can support better phone service, but also fixed wireless, which is big in the United States. And I think it needs to be big in India. We don't have enough fixed in India, and virtual reality and so on and so forth. And the next layer is massive machine-type communications. This is linked to IoT devices. And there's already, that has begun to happen rather slowly. And there are many other technologies playing there, NB, IoT, and others. But 5G will be much smarter in dealing with IoT devices. And the third layer, which is probably the most exciting layer, totally new layer, is ultra-reliable, low-latency service. So if you want to start interacting with machinery, particularly heavy machinery, or you want to interact with cars, or cars interact with other cars, you've got to make sure that the loop around is very, very small, 1 or 2 milliseconds. And also the links must be really reliable. And so the third layer, the 5G has brought in some technologies in order to support these kind of applications. So what is in green in the slide is largely already in service in some form or other in 4G, and also in some deployment of 5G. But the other areas are not yet been even standardized properly, and certainly not yet in deployment. And these will take another 2-3 years to begin to mature. I think it's full maturity around 2025. So where is 5G today? Basically, it's fundamentally only the EMBB service, that is extreme mobile broadband, is working. And we have the devices available are fundamentally phones and also CPEs. This is for fixed wireless. You have this device next to your, on your side of a wall to talk to the base station. India also needs to pay, US it's a big issue, but India also needs to pay attention to fixed wireless. I think the numbers are, they only have really good broadband to home, so only 8% have it. So 5G could be a good solution there too. And the picture there on the right is a mobile base station. The big antenna, rectangular antenna, that is the 5G in the mid-band, 3.5 gigahertz band. And the smaller antenna, actually a little yellow oval circle marked out, that's the 5G millimetric band base station, GNB. And so you can see that millimetric band things get really small. And the services today in the millimetric band is about 2 gigabits per second, maybe 3. And you can see a phone on the bottom there with clocking 1.3 gigabits per second. I see now phones even delivering 3 gigabits now in the United States. The big issue about 5G is that what does it really mean to the consumer with phones? We look at 5G as another G. It's fundamentally a higher speed, and hopefully low latency part will come in fairly soon. But also importantly, much lower cost per bit. So as you go to higher speeds, at the high bit rates, if you charge at the bit rate level, you're going to pay much more, but this will become cheaper. And mainly because the channels are much wider, and you can actually 5G technology is exactly as 4G, which is MIMO FDMA, and therefore there's no reason 5G should be faster. The only reason it's faster is because the channels are wider. It goes up to 100 megahertz in the FR1, that is the lower band below 6 gigahertz, and goes up to 800 megahertz in the FR2 millimetric band. So that's the little bit about the technology. Here is the global ecosystem, fairly up to date. About 40 countries have deployed. I mean, some of them are pretty small deployments, 75 carriers, and I think there are about 80 million subscribers today. The majority of them, 55 million, are in China. So China has rolled out FR1 in the 3.5 band in more than 100 cities. So they seem to be leading the way. I think the next big carrier deployment would be United States. We have deployed mainly in the FR2, the millimetric band, and this is by Verizon and AT&T. The technology deployed is EMBB, that is enhanced mobile broadband. The other 2 layers have not yet been turned on, and it's 95% is NSA. That is, you require a 4G anchor network in order to deploy 5G. So some of the signaling goes through the 4G system, and a standalone 5G will take a little bit more time. I think no deployments as yet. And so this is the transition mode, where it's called NSA mode. And most of what I mentioned was in FR1, that is in below 6 gigahertz, mainly in the 3.3 to 4.2 gigahertz band. And this, by the way, we in India deploy up to 2.6 gigahertz band at 2.65. So this is not that much higher. The FR1 is not that much higher the deployment. So it will look very much like a LTE system, and maybe slightly smaller cells because the higher speeds involved, the higher frequency involved, not that much higher. And the only reason you'll get more speed is if the government allocates wider channels. Today, our channels are 10 megahertz wide TDD, but 5G will support up to 80 megahertz. So the government gives 80 megahertz channels, then only we'll see a really high speed of 5G. Otherwise, we will not really see any additional speed. In terms of infrastructure suppliers, it's Huawei the dominant. And as you know, there's lots of political issues around Huawei, and the United States is on a war path. So it's not clear whether the dominance will last, but they generally seem to have the most mature technology and the most, probably also the cheapest. Then there's ZTE, another Chinese company, and Nokia and Ericsson have been there on for a long time. And Samsung also has, actually Samsung took an early lead in 5G. And in fact, my student, Vanil Rowe, led that effort some years ago in Korea. And so these are the major players. Semiconductors, which are largely relevant to phones, though we also use ASICs in these infrastructure too. The players are Qualcomm, which still remains the dominant one. Huawei, through HiSilicon, has also got a very reasonable chip now, probably similar to Qualcomm. Samsung and MediaTek. These are the major players. There's always a few more. And in terms of actually phones, LG and Samsung is what I see in the United States. Huawei phones don't enter here, but Huawei, Xiaomi, Oppo, the Chinese group have phones in 5G. I don't think many of them have an FR2, but an FR1 in the lower bands. ZTE also. And Motorola has also come up with a phone. The missing element here is Apple. Apple has not announced a 5G phone. I would suspect they will do that pretty soon. They actually acquired, Intel had an effort to build a 5G modem for the phone. And they spent almost $10 billion, but they couldn't succeed, to the quality they needed. So they sold that business to Apple for $1 billion. And Apple has been working with that team, and so we'll see what happens. Okay, so the another question really was, I suspect, around how will 5G evolve? And so I think the evolution really is back to this picture. We are deploying extreme mobile broadband. I would say the cut-in of the massive machine-type communications. The current technology, which is MIMO FDMA, has been used also used in Wi-Fi. It's also used in 4G. Has been sort of extended in 5G to make it more flexible. So the slotting structures, the way the control channels are sent, made it far more flexible. And then also the numerology is flexible. That is the subcarrier width and the slot size, or the channel duration and the slot size. So those will support the IoT aspects and also will support ultra reliability, low latency. In ultra reliability, the key element there is something called COMP, coordinated multi-point transmission. So the device that you're talking to will have multiple base stations talking to it in a coordinated way, and that will provide macroscopic diversity, and that's the key element of reliability. So these will take some more time. So I was mentioned a little bit earlier, I see generally all these things to be deployed by 2025. The base applications that will keep growing. The other day I mentioned in India that only 1% of 5G applications are visible now. We'll see a lot more will come. And India can play a major role in innovating in this area. And so I think I see, and also I believe the uptake of 5G is much faster than 4G. So we have reached 80 million subscribers in the last 6 months from the time it got launched, and 4G took a much longer time. 4G had problems with devices. We couldn't get the phones ready in time. I think 5G is not, 5G didn't have that problem. So evolution is, I think, reasonably clear. India is a different question. I'll come back to it in terms of Indian deployment. Then the question that sort of comes up in 5G, and it's also relevant to India's own development of 5G, which I'll talk about later, is that there's a big ecosystem called ORAN. This is called Open RAN. The idea of Open RAN is that 5G has got, as you know, it has devices sitting here among the UEs, that is the end devices, could be a phone, could be a watch, could be a car, and so on and so forth. So, and these then talk to the network. This is called the RAN network. 5G RAN, and 5G RAN is broken up now into separate boxes, the radio unit, ORU, and the DU is a distributed unit that contains some of the 5 functions and some of the lower layer MAC functions, L2 functions. Then there's a central unit which has more of the L2 functions, remaining L2 functions, and the PDCP SDAP. And these 2 elements are controlled by what is called a radio interface, radio intelligent controller, which I'm involved with a couple of companies. And these bring in optimization, orchestration, all sort of stuff, support this thing. And then the RAN then talks to the EPC on the 5G core. EPC is the 4G core. 5G core is slightly more expanded, and there are multiple boxes here. And the idea of the ORAN, the idea of Cloud RAN has been around for many years. Somehow never got fully deployed for various reasons. I won't go into it, but the ORAN seems to be now a big push to make this happen. The idea is these interfaces between these boxes are defined, because they're defined based on the 5G standard, 3GPP standard. But these interfaces are made open, so I can buy these boxes from different vendors and plug them together. It should work. This has always been the dream for wireless, but it's never happened because vendors tend to make this interoperability low, so that they can sell all the boxes to you. ORAN is an effort to open this up, and I think with the momentum, this finally may succeed. The one problem I see in ORAN is that if an operator, let's say it's Airtel, buys these boxes from different vendors, one from Japan, one from Korea, one from the United States, you normally go and buy the best boxes available. Even though they're defined on the Open RAN, when you put them together, these are very complex systems, making it work difficult. And the carriers don't have the skills to really system integrate it. So that layer is still missing. That people are trying to build those independent entities for system integration. So it's not clear how quickly ORAN will become reality. It is not there as yet, but there's a lot of effort. So I'm just following some of the issues that Uday raised with me. So when you go to 5G, and it's also relevant to what we do in India, there's quite a few buzzwords. One big buzzword is disaggregation and virtualization. So typically, if you go back into your phone, or a 4G phone, 15 years ago, when I was building chips for phones, we were already began to do everything in software. So we would have only some hardwired IP for the LDPC decoders or for the FFTs engines. Everything else was done on low power DSPs. I think I was using SIVA those days. This is 15 years ago in Basim. So things were done in software already in the phones. And in the base stations, they were getting into software, but sometimes they would also use FPGAs. The base stations have to connect to many UVs, and there's more workload there. So there was some, sometimes ASICs, but usually FPGAs, and some software too. An idea of virtualization is saying that you can actually have a normal data center with these blades, with normally Intel blades, with their own and connected by the spine fabric. So these are data centers which, when you do when you get on the web, you're landing. In fact, this call, AirMeet, is landing in one of these boxes where where all the videos are fused and so on and so forth. And therefore, the software and the hardware gets disaggregated. They're separate. You build the software independently and run it on these systems, and they don't interact that much. And virtualization is a similar idea, but in the data center has a different meaning, that despite whatever may be the underlying processor, you can, and operating system, you can abstract it and give any processor, any operating system abstraction to for the container, for this application to run. And so these are kind of interrelated words. But this is a big push now. And the idea is in 5G, these boxes will all run on the cloud, and therefore we get that advantage of disaggregation, virtualization, because then the hardware is commodity hardware, or white box hardware. Of course, this too is running into problems because in 5G, when you start talking about 10, 2, 5, 6, 10 gigabits per second, then the modems had to be super fast. And again, software may not be able to handle it. So we're now involved with a couple of entities where we are putting in special purpose blades, sometimes putting in blades with special ASICs in them, or sometimes putting in blades with FPGAs in them, so because the processors can't handle it. So the idea of disaggregation is sometimes getting watered down, but this always happens. Technology, we go sometimes 2 steps forward and 1 step back. But this is the area of disaggregated virtualization. Because of the structure, I think it makes it easier for people who don't have strong hardware skills, countries' strong hardware skills to enter the system, because software can play a role. And therefore, disaggregated virtualization will be a big part of India's approach to this problem. The core, the EPC and 5G has already been virtualized, and everything runs on software. This has been going on for many, many years. So that was the report on what 5G is happening worldwide. And I want to spend a few minutes about the DOT report. So there was a high-level forum, and the report was submitted in 2018. Our host today, Professor Uday Desai, was also part of that forum. And the report was brought out in 2018, and many of the recommendations involved the spectrum, regulatory policies, because 5G it will be a very different network. It's touching many more devices. So obviously the regulations controlling the carriers will have to be modified. And because it's no more just phones, and phones, because the people of India know how to use phones. A 5G phone is not that different from 4G phone. But cars and agriculture and transportation, they are different. They don't understand this technology. So the attempts to do education, awareness promotion programs, application use case labs, and to also get involved with application layer standards and participation in international standards. And then, of course, do some major trials and implementation oversight. So this was a big report, not a huge one, but written in September 2018. It's on the web. And most of the actions for it should have been done by middle of 2019, at least launching all these programs. I don't know where the status of the report is. I think I suspect Director General of TSDSI, Pamela, will know about it. So maybe she can give us an input at some point in this talk today. Let me go on further. So then I'm now going to talk a little bit about the industry and the need for India to sort of get into this technology. So this is not a good picture, but it sort of says, if we look at ICT, that's information comm technology, I would look at it in kind of 3 layers. My view would be the topmost layer is where we see it ourselves. When you get onto Paytm or when you interact with social media, you are picking up one of these applications, whether it's economic, societal, or security applications. So those are the application layer which actually the end users touch. But to do that application, including from AME to an application that we are on now, they actually are offered by certain on infrastructure delivered by operator services. So data centers, we have quite a few of them operated by various companies, mostly foreign companies, Google, Amazon, others. And then we have wireless operators, Geo and Ping, and then AI operators that will probably not come in, and of course, World Wide Web type operators who provide internet services. So these are the operators who are fundamentally, they actually then finally buy the technology to put up these services. So the actually chassis and antennas and radios. So and then those built on chips, semiconductors, and there's a lot of issues of patents and intellectual property. So this is called core ICT. So this is the foundation of all these systems, and this is the price of every country which has wants to be a play in this area, would like to get into this technology. And And I think the big issue in India for more than 2 decades has been how do we break into this industry? Our presence today is fairly small. We have some good companies. We have Tejas, and we have Tech Mahindra, and a few others, but still very, very small. And we really need to grow this. And so core ICT refers to the equipment and end devices, which of course depend on semiconductors and advanced components, and all of them depend on IP. So this is the big IP is the big area. So this is the stack, and this is the focus. We're doing very well here, and we are moving and building applications here. This is an area we don't have much presence, and it's critical. So once again, looking at the core ICT, this is the structure. We can look at this my view structure. One layer is IP and design. There's people who design this system. They actually don't build anything themselves. They design it and they hold the IP. So at a systems level, example would be Huawei, or it could be Nokia, or it could be Apple, and then these are system level guys. And then there's another part of industry who design semiconductors, chips. And much of the action of anything is semiconductors. And so the semiconductor design and system design are the design layers. These guys actually never touch hardware, except hardware comes back to them. They could make sure it works and so on and so forth. And then the manufacturing layer, which is fabs, manufacture semiconductors. There's all the advanced components like screens and RF components and the sensors and actuators and such things. And then, of course, finally, assembly and test. When all the components are available, the design is in place, you're putting it together into a phone or putting together base stations for assembly and test. And this is how we see I look at the core industry, core ICT industry. And just looking at this size of this industry, the EBITDA, earnings or value addition by each layer of the industry. The design layer globally is about 320 billion. System design is about 600 billion. Manufacturing, semi-sim, it's about 510 billion. Other components, 110. Assembly and test is always small. It's not a very highly skilled job. It's about 70 billion. Total today is about 1.6 trillion. And in 10 years, that will probably become 3 trillion or more, or even maybe 4 trillion. So this is a very large industry. And just to give a little bit more example of a smartphone, if you buy a phone, say $600, brand XYZ, and you buy it for $600, $300 goes to the phone guy. First, his R&D of putting the phone design, his operating systems, all those things, plus his own operations and his profit. And $300 goes to manufacturing the phone, of which about 76% is semiconductors. 12% would be display, other component 9%. Labor is about 3%, 4%. So a lot of phones are assembled in India. In fact, Bhaskar tells me all the phones are assembled in India now by various Chinese or Korean firms. And so when that happens, only 3% actually comes to India for labor, because all other components tend to be imported. And typically in a phone, you can see the BOM. You can see the BOM here. It's all mostly semiconductors. And it's all given here, but take this guy. Typically, there will be about 11 companies involved in these chips, sometimes more, primary companies, and those companies may use other companies to build their pieces. So, for example, when I was building chips 15 years ago, even though the primary chip was marked as our chip, Basim, we probably had IP from about 5, 6 other companies. And the chip itself went through about 5 or 6 different stages of manufacturing, from fabric, from diffusion to dicing, testing, packaging, layering. So many went to many countries. So this is a very big global ecosystem, and nobody is independent. Nobody is self-sufficient here, and so it's a big engine. There are now new threats because of the US-China dispute, but right now this is how it stands. So, something about the industry itself. It's core ICT refers to equipment, infra, and end devices. And the key countries are China, now become the dominant, US, Japan, Korea, Europe, South Korea, Taiwan, Israel, and Singapore. I think I would put this between these countries, we probably picked up 99% of this market. Total R&D in this segment, core ICT, this is not just 5G, I'm talking about entire area, is about 220 billion per annum. And no country is self-reliant. It's a global supply chain, and I remember when I was doing chips, the chips would they would finally be warehoused in Hong Kong, but they would go from Taiwan, from TSMC, to Japan, to South Korea, to Singapore before they finally were ready for. So it's a big supply chain, almost entirely in the private sector, and most core ICT companies that we hear of normally are multinational because this is required. They have to sell globally, and they need talent from globally, so they tend to be multinational. But they themselves rely on, whether it's Intel or whether it's Qualcomm, rely on R&D globally, and so they have global markets and global R&D, but they incorporate technologies from smaller companies. And it's very ultra competitive. Only the very best survive. Typically, the rule is the top one gets 80% of the market, the second one gets 20%, and there's nothing left for anybody else. I mean, that's an exaggeration, but it's a very competitive area and very big entry barriers. This is partly how the industry is structured, but partly how the government, which controls these companies, also structure it. For any government, this is the crown jewel of their technology, and also they pay a lot of attention to protect it. So India, of course, needs a core ICT industry. We actually have a lot going on in India. We have lots of MNCs doing lots of designs. I won't come to see him. We were doing WiMAX modems, but much of it was done in India. So we're doing first-class work in India. MNCs do that work, and Qualcomm, Broadcom, and others. And we want them to expand and do more, more jobs to India. And of course, there's lots of work being done as design services, where our own software companies are doing a lot of, and Wipro are doing a lot of service work for other companies. So Wipro does a lot of design services for Cisco, and I'm sure of Intel and others, and so does Infosys. So all that is done. So those are all doing very well. But what we lack is Indian headquartered companies in the ICT area, product companies. We don't have Indian headquartered product companies. We have everything else. And the value of Indian headquartered, I'll come to it in the next slide maybe. But the imperatives for the national security, I think that's the main one. Certainly global influence, import burden, and of course great jobs at multiple tiers. Now, of course, you can see the huge fight between the United States and China. It's really about Huawei, and really about 5G technology. The US now has found, unfortunately, the Chinese have much better technology, and that has become a huge worry for the United States, because in a very core technology, and technology really decides a country's influence and stature. US might have lost the race in that particular area, so they want to catch up. And there's huge effort in the US, which I'm also involved in trying to make sure that US regains its leadership. So therefore, most of it is linked to national security. So I think India too must have some element of this base to make sure that we too become a player here. So I think my goals which I have, personal goals for India would be, India, we are still so small that we can't build everything overnight. It'll take some time. But I think by 2030, I think we should try and pick up 5% of the global market share. That means we have to grow our base of value addition in core ICT. Forget about assembly of phones, but in design companies, and perhaps even semiconductor manufacturing, to about $200 billion. So that's almost growing it by something like 500 times from where we are today. And I think out of the top 100 global companies in the world, we should have 5 of them. And because the global companies is how things are delivered, so we need to build that layer too. And we should also control or have 5% essential IP in very variety of standards. And that is not to rob anybody else. We want to see the multinationals growing in India and functioning. We want to see the design companies doing well, also coupled globally. But our growth of Indian headquartered companies will actually help them too, and they will help us. So it's really just making sure that we participate in the market and not be left out. So this is not to rob. It's not a zero-sum game. It's a win-win game. So the government, every country I'm involved, I know quite a bit what happens in China, and certainly the United States. I've been in so many committees. The governments are very heavily involved with the development of ICT because it's such a foundational technology for the country for various reasons. And they're generally involved in various ways. One is to attract venture capital. And the US has done so much of work in this area to make sure venture capital funds entities and also supports these young companies with connectivity. In fact, I'm on 4 or 5 companies now, 5G. Within 6 months, these companies are talking to other global companies, building up partnerships. So it's a very big global web of companies, and the venture capital helps that connectivity also. So the variety model from various companies, and I think I saw the report from TSDSI, which has done an excellent job. I should also ask them to look at the Australian model. But the government is heavily involved, including in the United States, in making sure these private sector companies get funding, risk funding. That's very important. Second one is, of course, it happens like in India, and it happened in China earlier. A lot of it is imported, and the government policy helps leverage those imports to build local capability. China did it in a particular way, and I think people were not happy with it. India has to find its own way, but we buy a lot of technology, and we can't go on forever. We need to sort of join the club. We don't want to be. There's no such thing as being self-reliant, but we want to be part of the club. And the third thing is support. And government can support it through government purchases. The WTO allows this, but WTO is pretty much dead because USA seems to have withdrawn from it. Things like preferential PMA and taxes. So many things government can do to support this industry. I was involved with some efforts in the US back in 1993 when I came to Stanford. And if we tell you the story, you'll be amazed at how much the government did to promote this industry. And I think also attract experienced talent. In India, we have building systems. We have lots of knowledge, almost as good as anything anywhere in the world. But we still don't have business development, market understanding, product management, that kind of skills of all these MNCs don't bring to India. All that is sitting out here, or sitting in Beijing, or sitting in Silicon Valley, or in Hong Kong. So there are lots of people we can bring back who can bring the talent, that kind of talent that we don't have. So the government must various ways doing it. China's did it in a very big way to take people back who can teach them how to enter these markets, and also to build something like a core ICT city. My dream is create a small city with maybe 5 or 10,000 companies are sitting there, and many will be born, many will die. But that's how the survival of the fittest. But by being close to each other, that Shenzhen is a good example, Silicon Valley another example. It's enormously helpful. Of course, in the COVID area, I don't know how that will work, but that was the pre-COVID views. So the government has to play a role. And if India, we have not done well in core ICT, the government has not done this job. And I think the fundamental reason why it's not done the job is, there's nobody in the government who understands this industry, all its barriers, how hard it is to get in, and then put together a pan-government policy which can actually make it work. And in our government, I think it's always execution in this area, which is not well known to the government, is difficult. So I always felt that this sort of thing should be a national imperative and should be rightly under the Prime Minister. In fact, as such, it should be a commission, and the PM should take it as the be focused for India. And we can, if we can crack this technology, and this is technology for foundation, all the future technologies for energy and for nano and bio. Nothing can do without this technology. We don't crack it, I think we'll have much more handicap elsewhere. So this is the big foundation technology which government should do, and I think it has to be done way it works today in India. It must have the direct attention of the Prime Minister. Not going to be easy. This is very difficult, but it can be done. We certainly have the ability. Okay, so there was another question that and Uday, when you hear me, you can always stop me if I'm going too long. What about electronics manufacturing? And my point here is there's lots of, we do a lot of phone assembly in India, and at the political level, they think we are manufacturing things in India. That's not quite true. I know if you look at the core ICT, only that assembly and test is going on in India. And that, if we just do assembly and test with all the parts come in and we put it together, maybe we populate the PCB sometimes, even that we may not do. The value addition is only about 3 to 4%. And so that's useful. It creates low-level jobs. And I think China, of course, the leader, but Vietnam has done, I think that went to 100 billion last year. Top line. The bottom line is they would have got about 3 or 4 billion of value addition. And we should grow this, but that is not manufacturing. Real manufacturing when we can actually touch all the boxes here. And so that should be where we need to go. We are well in this area in the bottom, and these are mostly MNCs, Foxconn and or Samsung, and fine. I think they can certainly do it, expand it, but India needs Indian headquartered companies in these other boxes. Okay, so a little bit about what should be our approach there. Now, this is, I have to be humble. I've been coming to India in 2019 about 8 times to visit with PMO on some of these issues. I won't go too much details, but and I think there are other people here who know India better. But fair is talking about 5G. 5G, remember, is, even though it's a radio system, it's almost all computing. It's fundamentally, except for a few RF components, everything else is just computers running here and there. So it runs in computing, and now AI is being integrated into the system and so on and so forth. So, this is the top bottom picture is 5G and those boxes there. And the question is, to enter 5G, we should enter on some or all these boxes. Which box you want to pick up? And of course, I think in every box, we need to have competition, because it's very, that's how the world functions. And even when we build any boxes, we should be quickly connect with the other players in the field. We should not just talk about selling to India, but we should try and sell to, every startup does that in the world, so we should also do it, be fully engaged with the ecosystem, and also have internal competition between people. These are not small, simple things. Anybody serious about these things are working 60 to 80 hours a day, a week. And so we need to get that competition going. And if O-RAN finally plays out, then it means that we can build some pieces and yet be a player in 5G. Building everything, it may be difficult because the global ecosystem started 4 or 5 years ago, building some stuff. But the industry is already sunk in many tens of billions of dollars. So I think we should pick and choose here and not take on everything. I myself involved quite a lot with the NIRC, the radio intelligent control area, quite a bit. And then in this core ICT picture, what should you do? Semiconductors and semiconductor fab, I think any reasonable fab will take many years, and it's not, 5G, if you want to be serious about 5G, we need to get something in the market within 2-3 years. So that may be difficult, fabs, but semiconductor design, to extent we can use O-RAN architecture, may not need too much semiconductors, so that's not such a priority. The real priority is systems, and that is systems knowledge. And from all my work in this area, it's only systems knowledge that finally matters, knowing how everything works. And that's the most valued knowledge. Once you know that, building chips and all that is much easier. So, but system knowledge is a very, very precious knowledge. And that's where I think we also have that in India. So system design tech companies, which may not necessarily start getting into semiconductors and fabs and all that, advanced components, that can be done over the next few years. And of course, assembly and test is already being done, and so that's not an issue. So, and also I should say that plenty of excellent 5G work by foreign headquartered companies in India, in product design, a lot of it is being done in India, and Indian and foreign headquartered company design services. All that should grow, but India should also, check in with its own companies at least in 5G in the systems area. So I think let me say a few words about 6G, and then we'll go into Q&A. So 6G I'm on a couple of committees on 6G now. And sometimes my calls go earlier in the morning or much later at night to deal with international timeframes. This is, it's a big wish list. There are a lot of papers coming out. I'm also working on a paper myself. But I want to keep telling everybody that we must incorporate feedback in 5G. So 5G, of course, is not yet deployed properly, but in 5 years, we'll know a lot more about it, and bring the feedback in 6G is important. Another thing that will happen is terahertz band. Right now, 5G goes up to, I think, 70 gigahertz, non-licensed bands. Licensed bands go up to about 49 or 50. And with licensed bands, unlicensed go to 70. But this will go beyond 100 gigahertz. And at that time, the links become pretty small. A few tens of feet, maybe difficult to go 100 yards to 200 yards, and visual light communications. This has been around for a long time, but for a variety of reasons has not been successful, but I think these are new frequency bands. Satellite, this is a big opportunity for India, because if you want to deliver really high bandwidth services to rural regions, you can't do it by terrestrial. There's too much infrastructure. You want to be on a train and be able to browse your phone with 2 gigabits, so you need a base station every 100 yards, 200 yards. You can't do it. Satellites can do it. So there's a lot of push in satellites. Broadband satellites will come. There are lots of startups now happening, but I think they're all fragmented. We need the standards, so 6G will probably help that happen. I think a big area for opportunity for India. We need it in India for our services, but also we do have capability in space areas. So then moving away from cell-like architecture we have today to cell-less type architecture. There's really a variation of comp. And of course, today we use multi-user MIMO, massive MIMO. We're already heavily deployed in the band 41 in India in the 4G area. It's, of course, coming in 5G, but distributed MIMO. So antennas not at one base station, but there are many base stations. And this has its own challenges, but some advantages too. This is key to cell-less ideas. And area that I'm involved in now, deeper AI optimization in optimization orchestration. So optimization, orchestration, virtualization, cloudification, these are the big buzzwords where a lot of companies are being built in 5G. And AI is coming in. It's still, it's easy to say I'm doing it, but actually getting AI to really work has been difficult. I've been looking at it for some time now, several years. But it's coming in slowly, so deeper use of AI will be a big goal. Certainly more coverage, certainly 3D type coverage, so UAVs and things like that, cell-less architectures, and improve support for AI applications. Now AI applications are already high, but growing, and how does 6G support that? First of all, AI is going towards more distributed type learning architectures, a lot more security, homomorphic computing ideas, and where everything is secure, including when you're running the inference engine, both the engine weights as well as the data is kept secure. Nothing is opened, and so how do you support all that in the wireless network is also an issue. Active reflectors, a lot of work going on, metamaterials, power transfer. Quantum dimensions, there's a lot of talk of quantum encryption, of course, and a lot of demonstrations around the world. So this is a big wish list, and a lot of white papers coming out. And I don't know when 3GPP will get involved, but I suspect in a few years from now. And we have people looking at launching in 2030. So with that, I will get out and get back to Uday and take some questions.
Okay, let me unmute myself. Thank you very much. Really a very enlightening and inspiring talk. You covered everything, that is technology, the global scenario, and more importantly, from our standpoint and all the members who have joined this particular webinar, is what India can do, what role India can play, because that is always a question in our mind. So I'll take up a few questions, and then I hope Prashant will help us so that people, the audience will be able to ask some of them. Okay. So you have covered quite a few things. One of the things is about the spectrum allocation. You think India is going very slow? Should we kind of speed up the spectrum allocation, or which spectrum should we kind of open up first? The bandwidth. Any thoughts on that?
Yeah, I think I've stopped interacting with the government on that issue. Let me take the easier ones first. The easy question is, which band should we deploy? Typically, I think in India, I would see it to be FR1, open up 100, 200, 150 megahertz in the 3.5 band, and allocate wide channels so we can get, if we go back to 10 megahertz channels, 5G is same as 4G. So allocate 40 or if possible 18 megahertz channels. And that will be difficult to give to for multiple carriers. So we need to open up maybe 300 megahertz 3.5 band, FR1. Okay. China has gone this way, most of the world is going. So I would say the lower bands. Telemetry, I'm not sure there's a business case in India right now, maybe a few years later. Regarding opening up these spectrum auctions, I think it's tied up with the issue of base pricing, and the also have financial issues. So there's a lot of these are political level decisions that I won't get into.
Sure. Yeah. Now the other part was, you mentioned this whole concept, and it kind of covers lots of things. Setting up a ICT city. I think that's really a profound concept, and we have set up research park. Of course, you're familiar with the one at IIT Madras, which has now become, and similar ones are coming up across all IITs and ISC. In a sense, what one is looking at, will that necessarily be the solution, or if it is still running in the same model like any industry is running anywhere in the country, how would that make it? See, we went through this CES, and if you are familiar, there is something called Sri City. It's about 2.5 hours, less than that, maybe little less than 2 hours from Chennai. It's near Nellore, almost bordering Tamil Nadu, but in Andhra Pradesh. And that was a model which was sort of talked about. Sri City is like a self-contained industrial park. So should it have CES, some tax-free models or something like that, which will motivate people to go there and then start the manufacturing activity in electronics?
Right. I think the SEZ, in fact, Shenzhen is an SEZ, and SEZs have a checkered history in India. I think the idea of the city was more like this: is proximity of companies, because in business, a lot of companies are born and many will die. You know that. So I think 70% are going to die. Yeah. And only the fittest survive, and that is the only way these things work. It's race to the top. So and then the idea of the city is that somebody makes a career in the city, he joins one firm, it may grow into a mega firm, or it may die. But he's bought a house, children are in school, he doesn't have to move, he can jump company, hop company, and every time he hops companies, he takes knowledge. So Silicon Valley's success is that, like when I did my last company, this is Raza Networks, I could see that the average number of companies, the staff was there before they joined me, was in 7 companies. So every company they bring in knowledge. So that knowledge circulation is critical. So that's what, therefore, being in a geographical local area gives stability for the family. So those are things.
No, that is one part. So I agree, knowledge circulation. But the point is that should there be some tax incentive? Should there be that if you are selected for that particular city, you get some some specialized funding, etc., etc.?
I think so. I think some of those packages can come. For example, the Israelis have done a lot of this. I was there recently. Some of that we have done software technology parts earlier with some models like that. So the infrastructure part and those are the simpler things to do. Right now, everything is about talent and knowledge and holding on to that knowledge, circling. So I think I would put that as a priority for the cities. But certainly, the easier parts I think should be there too, of course.
Yeah, it's wonderful. I think it will be good for TSDSI or some group to look at some kind of a white paper on this. I mean, we'll come back to you and take your help if we really try to go forward with it. Then the other thing, of course, you covered 6G. Now, so what I would say in 6G domain, we have satellite things, but our satellites are not as pervasive, in terms of covering the whole Earth, like the ones that are there by other countries. So, I mean, you think SpaceX is the kind of technology which is going to make a big mark out here, or, or should is it that right away now India should start investing in 6G like we did with the test bed, but much bigger investment, because 10 years is enough time for us to become a player rather than getting into it in 2025 or 2026.
I agree. So I think 6G, certainly 6G is more than satellites, and I think our goal, as I mentioned, is by 2030 when 6G comes, at least if you have 5 companies globally known in ICT, at least one should be known in 6G, and we should have 5% of IP, and all that should be done. But so the exact models, what we do in universities, how do we drive it forward? I think I'd like to think more, but we need to do that. But talking about satellites, the way of delivering broadband to rural thin market areas is really satellite. You can't do it terrestrially, but these satellites are very, very different. They will contain tens of thousands of elements, which are not been built before, and so they use MU-MIMO, tens of thousands of elements. And I studied this area. In fact, the big challenge is the feeder link. On the access link is a little easier, but there's completely new kind of satellites. And so, I mean, launching them, all that may not be, I think the launch is not the issue. The issue really is system design of these satellites and what orbits LEO, probably LEO because the latency comes too high. So there are a whole lot of things to be done here. And I have a feeling that because we want to make sure rural people also get broadband, which is the global thing, satellites will probably become really, the current projects are all baby projects, but the big project will come with the standardization. Because of standards, things happen. And therefore, I think if 6G can come up with a standard, India has an opportunity, I think, to play a role there because it's going to be very different. So a lot of people in 6G will benefit from 5G background, which we may not have so strongly. So 6G is a clean slate where we can actually become a really global player.
No, so then it brings two questions out here. One is you have worked in the Indian strategic sector. You were with the NPOL or Naval Labs, with the Navy, etc. Now, how do we create this kind of a collaboration for 6G between ISRO, academic institution, and industry? Because ISRO is fantastic, done a great job, made India very proud, but it is in a sense by itself. There are small cells which have been set up in some of the IITs, but the work there is like, and there was one in Bombay also, but not of the magnitude that would be required to really get into 6G. So what strategy one should have to bring these bodies together?
I want to bring out ISRO. We are very proud of ISRO, and they did a good job. But remember, ISRO builds stuff, and they are their own consumers. They build it and use it themselves. In the ICT industry, when we build a product, technically that product has to compete with the best in the world. Otherwise, we can't sell. Yeah. So we have a vastly more complex situation. And that is the ecosystem by which we benefit. We can get these phones and get this enormously incredible technology we are using right now, because it's a global ecosystem of ultra competition. And so that's why it's so much more difficult to get into this market. So the ISRO model is not a market model for us. It has to be a model which is right now functioning in the ICT global ecosystem. But what I would say is that in terms of how do we build R&D towards 6G, My thinking would be is to create some pan-university partnerships. We're already doing a little bit of that in 5G, but much more of it.
Okay.
And but anchor it in universities for some time, and let's say keep it for 5 years. And after 5 years, assuming we got our act together and we have access to a lot of venture capital, we should launch a whole bunch of companies in different segments of this area. And then some of them will survive and become global players and so on and so forth. So initially academic, but multi-institution organizations, and then moving towards getting that stuff spawned into industry, create startups, and let them fight it out. And one or two will survive, and then take us there.
Sure. So a couple of questions before I hand over to the audience is. So you talked about semiconductor manufacturing. Now, as you correctly mentioned, setting up a fab is going to be not just expensive, but it's a very long drawn process. And my personal opinion has been, in India, maintaining a fab. I mean, that's perhaps far more critical because I've been to Taiwan and occasionally seen a bit of US. I mean, the fab that they have out there. So I think, what do you think of FabC? Should we really go all out in having fabless chip design? Centers, companies, or whatever you call it? Should India promote very actively fabless chip design? Then we tape it out and get it fabricated in Taiwan.
That's how the whole world works. I mean, there's an entire system design industry, systems design or semiconductor design. And my own company, nobody does fabs anymore. Okay. So, but fab facility is something which is now. There are about 30 fabs in the world, and the players are, Taiwan, China, United States, Japan, South Korea, a little bit in Europe and Singapore, and so on and so forth. I think India, with size, we are a big country. The question is, should we have a fab? Mm-hmm. I think an answer is yes, but it's a lot of question mark because, first of all, if you want to really a modern fab that is talking about 7 nanometers, it's probably $25 billion. Okay. Plus, we don't have the skills for that. We simply haven't built that. To build a 7 nanometer fab, you should have gone through all the previous nodes. Enormous skills are needed. We don't have that. And more than that, you got to run into the business. Now, these are cutthroat businesses. To survive, you got to compete against the rest of the guys in the world and win. And as you know, many fabs are in trouble. So all these things are question marks. But nevertheless, strategically, India must at some point have a internal fab, which of course not only internal, but we are so successful that we open fabs around the world, but it's Indian headquartered company. So it's a long way to go, a lot of investments. So I think by 2030, we should be on our way, and it'll require massive investments and different kinds of partnerships. So I think we need to get our design layers started going, but fab, I think, is not something we should ignore. It should be in our mind, but remember how it's complicated.
Thank you. I like just two quick questions, and I like your slide 17. Where you talked about what India can do. This 5-5-5. 5% of global market, 5 out of top 100 global companies, 5% of essential global IP. I think, and you said we should be able to do it by 2030. Is it possible for us to expedite that, or it's going to take? We will have to take another decade to do it.
Well, China did it in 10 years.
Oh, China did it in 10 years. Okay, I see. That was really.
I mean, until 2005, they were kind of really not in the picture. But today, they've done it in 10 years. We can do it, and actually, we have advantages over them because they came from a manufacturing background. Mm-hmm. into IP and design. So we're actually already there in IP and design, except they're MNC companies. We need to have Indian headquartered companies. So we have a much better path there, and I think we can definitely do it. It's fundamentally leadership. We need to find those key people, those leaders who will take us forward. It's all leadership and people, and we have them.
So you think our IT companies can actually now foray into communication? Like you said, We don't have the boxes that you had. I mean, we had very little play in those boxes. We are. I mean, practically, I'm being a little harsh on India, that we are practically nowhere. We are in assembly and testing, which is very low end kind of thing. But so should I? IT companies which have made it.
Can't hear you.
Are you able to hear me now?
I'm okay now. Thank you.
No, what I was saying is that should our IT companies, like I won't name names out here, the giants which are there in India, they're all multi-billion-dollar companies. Should they get into core communication technologies? The boxes that you had sort of showed out there, with that one slide, very indicative slide.
Well, certainly Jio's made announcements. I met Mukesh Bhai in November last year. He told me about it. Anyway, so I will just leave Jio out of this. I'm sure they're doing some good things. But the typical, software design services companies, engineering services companies, Infosys and Wipro, all of them are looking at this, but they see it as a service.
Yeah.
So, if you go to Infosys web page or Wipro, they'll say, we have these capabilities, give us a contract, we'll design it for you.
Okay.
But they're largely not in the product mode. The trouble with for them to get the product mode, then they compete with their own clients. Clients are building products. Yes. They can't compete there. So they are largely, in a different model, a very successful model. I think it's hard for them to transition. They've tried. I think it's hard. I think we really got to grow this up from grassroots.
So I would now request Prashant, is it possible to open up so we can take some of the questions? Nobody seems to have raised their hand. How do we go about it, Prashant? Can we invite some questions from all the participants who have logged in?
Yes, Professor Desai. You could just invite people to raise their hand and then we can allow them to.
But I don't have any controls. I think one Satish Sinha has raised his hand. So he needs mic access, Satish Sinha. So I would request people who have some questions, please raise your hand and we will try to accommodate you. I mean, we may not be able to accommodate everything. Okay, currently Satish Sinha is speaking. Please go ahead.
Yeah. May I speak, sir? Professor Desai?
Please go ahead.
Yeah. So this is I come from IIT Hyderabad, and I'm listening to this discussion since beginning. Since we are talking of 5G and then also you raised 6G, and sir has shown us a slide of human-to-human interaction, then human to machine, machine to machine. Ultimately, again, it is a human-to-human. Because when you talk of vehicles interacting with vehicles,
for time, sir, I request you to ask the question.
Yeah. So the question is that can we also evolve through 5G evolved or 6G into quantum analog computing this way? Because few things are missing when you go digital. When you go digital, they are at the cost of some emotional component or some other things which is not able to be captured unless it is quantum analog computing. So are we also moving towards that direction? My question is that.
Yeah, quickly, So quantum computing is still a question mark, and of course, quantum computing is very different from digital computing. And I won't get into it, quantum computing is it's not even clear whether it will actually function, though I think it's likely to. So I would say it's just a computing layer, and if at all 6G gets into it, it'll just be another box in the data center where it'll be doing certain problems. And quantum computing can't solve all problems also. So I would say yes, there's a role for it, but it's very early in its technology.
Okay, we'll take another one. Prashant, we can unmute. Let's try Manoj Beligaonkar. Or Belgaonkar. Okay. Manoj, go ahead.
You can start your camera as well, Mr. Manoj. And all the attendees who are going to be on the stage, I request you to start your camera.
Okay, I'm not sure because of the bandwidth, because I'm not able to see.
Anyway,
Manoj, yeah.
Question,
so
the camera because
yeah, that's yeah. So My question is, I think Germany has tried a private 5G band. So, do you think such kind of a policies are also present in other countries for a faster adoption of 5G in industrial applications, especially from IoT point of view?
Yeah, that's a good question. True. I think the 5G business models will differ from 4G because it's not just phone service, but also factory automation and many other services which are only used, will probably only be used by a particular entity or enterprise. So 5G will definitely need, I think, private operator models, and that also means spectrum in that area. So you're right. I think it will not be a universal carrier model. It will also have private models, and the spectrum allocation and auctions must support that kind of model.
Yeah, thank you.
Thank you. Okay, maybe we can try next person, Parag. Okay.
Thank you, sir. Can you hear me?
Yes.
Yeah.
Please
Okay.
go ahead.
So you mentioned that the 5G frequencies would be 3.5 gigahertz and above, and have seen a lot of documents which are much higher on the spectrum side. So would these higher frequencies affect the indoor coverage? And in order to take care of the indoor coverage, for example, do we need to actually re-engineer all the backhauls? Would there be a kind of a major cost in establishing the new backhauls for every band, the frequency band, because each will have different propagation characteristics and losses in the urban, especially dense urban areas? That's the first question. And the second one is what frequencies would be used for the 6G, and why are we not using the 450 to 700 megahertz spectrums, which could be for, let's say, the static, not really fully mobile stations, especially to provide, say, static broadband in rural areas.
Parag, let's go with one question at a time. I think Prof. will just,
Okay.
So,
Yeah.
I think everybody will get a chance that way. Prof. Paulraj.
Yeah, let me answer. 5G will, has new bands, but 5G will also have operate in other bands. 5G will operate in 700 megahertz bands. So when we talk about new bands, all the previous bands remain. It's just that those bands are added in. So that's one comment. The other question I think about backhaul. It turns out in 5G we have three kinds of backhauls called front haul, mid haul, and backhaul. I won't go into it, but backhaul, is transparent to the technology. Backhaul for 5G or front haul for 4G is very similar. The only question is the speed required. In front haul for 5G, right now we need about 45 to 50 gigabit per second, but it will go to terabit per second once we open up the band and go to higher speeds. So, but backhaul technology will change because the demand will change because we're pushing in more data because of our 5G operations, but not the technology itself. 5G indoors, as a purely like a Wi-Fi replacement, I think it's not being used with that. Outdoor to indoor coverage is an issue in 5G, and I'm involved with the company building relays for that technology, for that application. So there's a lot going on in 5G, but in terms of bands, no bands are being abandoned. 5G will also operate in 700 megahertz bands, or even 6G will operate in 700 megahertz bands.
Okay, can we move to the next one? I think that lots of people.
Professor Desai, may I come in for a minute?
Sure. Please come in, Bindu.
Thank you. So it's already 7:20 p.m. and we've overshot the webinar by around 20 minutes.
I know, but 20 minutes, yeah.
Permission from.
But I think there is a lot of enthusiasm. I think we'll take 8 more minutes. We'll go till 7:30 India time.
All right,
7 a.m.
Professor Paulraj,
Will that be okay with you?
if you could.
Well, I'm fine.
Yeah, he's fine.
Okay, thank you, sir. And Professor, there are several questions in the question tab.
Sorry?
There have been several questions in the question tab. If you could also.
Yeah, okay. Yeah. No, I think let's go live. I think Krishna Surohi is there. I know him, so I think I'll give him a chance. So can you give Krishna Surohi a chance, Prashant? Prashant? Krishna Surohi, okay. Krishna, go ahead. Can you hear us, Krishna? I don't know. You provide a mic, he's not saying anything. Okay, it looks like Krishna. Oh, there he is. Okay, go ahead, Krishna. Yeah.
Yes. So namaskar, Dr. Paulraj and Desai. I had, as always, it is very inspiring talk. My question to you is that the way the 5G is graduating from release 15 to 16 and 17, it looks to me that 5G itself will have multiple waveforms. Then do you consider or do you suggest that the implementation of a 5G layer 1 should be something like on the principles of SDRs, so that you can have a selective waveforms for a particular use case?
No, hi, Krishna. No, but it turns out the waveforms is a very military, SDR term. 5G has actually gone back to its roots. The original root was MIMO FDMA. Actually, it came out of a company called IOSpan, which I had founded maybe in 1998. And that became WiMAX, then Wi-Fi, then 4G adopted it. But in 4G, we actually changed the uplink to DFT control, DFT coded as OFDM. And but in 5G, we've gone back to straight vanilla OFDM, MIMO OFDM. So the waveform is only one waveform, and there's no change in waveforms in the system. And secondly, about SDR means software realization of the system. That's been for 15 years. As I mentioned earlier, 15 years ago, I was doing phone modems entirely with software, except for some accelerators. And today, the problem with doing it software is that the computers can't do it, can't deal with these kind of speeds on links. So you're sort of getting back away from software-defined systems back to ASICs and to FPGAs, which are, of course, very expensive. So it's a kind of a moving target.
Okay, thank you. Maybe we'll take a couple of more questions on it. I think next in line is what? Krishna Kumar? Go ahead, Krishna Kumar. What happened? Is there any difficulty with the mic or something?
No, I think he has to accept the request to come on the stage. He's not here yet, I think. We'll just wait. I think we'll move to the next one.
Next one. Okay, so we can pick somebody else. Okay, Jitendra Garg, let's try him. Yeah.
Sir, are you? Yeah. Sir, my basic question is this: in India, our income is around $2,000 per annum. And when we are comparing the technology with China and USA, their income per annum income is far, far superior than us. China in range of the $6,000 per annum, and United States maybe $25,000 per annum. So when we are comparing the technology with them, but our basic investment, people don't have the investment to do something in new technology, and 50%, around 50%, they don't have the reliable coverage right now. And we are talking about the 5G and 6G and other future technology. So in my opinion, this technology will be limited to the certain segment. So how we can these underprivileged community can be come on the board? That is my question.
It's a big, very important area. I'm on many committees on digital divide in the United States. But one thing I would say is that actually we've done very well. In 4G, our cost per bit, cost per gigabyte is the lowest in the world. Lowest in the world. So our carriers, we know how it all happened. Have done a fantastic job of making systems very affordable. I mean, certainly, I think I pay 100 times more than I pay in India for gigabyte here. So we've done very, very well in deploying services. So I think we will do exactly the same, similarly well in 62. We are geniuses at getting the cost down. And so I'm very confident of that. Of course, there is rural coverage where people in rural areas, villages, and moving between villages, they should also get a reasonable broadband capability. In 5G, in 4G, I would like to see at least say 3-4 megabits downlink and 1 or 2 megabits uplink. We don't have that today. I think our real coverage at that level of rural population is about 10% or so. Even though their claims made is 98% coverage in India, that is not true. And so we need to bring the rural population up from 10% to about 50-60%, where they get reasonable broadband service, not just only inside their homes, but also when they are in the fields and so on and so forth. So rural coverage is important, and I think 6G with satellite may make it much easier, but nevertheless, that will remain a challenge. But in terms of cost of affordability, of course, even at 200 rupees, it may be difficult for some of us to afford it, but we are the lowest cost in the world. It's actually miraculous.
So shall we stop here? I think it's 7:29 as per my watch. So I think we just hit 7:30. I think we have covered. There are lots of questions, both in the question box as well as many people have raised their hands also, and it will be difficult to accommodate everybody. So I would take this opportunity once again to thank.
I would say a few words.
So please, Professor. Yeah. Please go ahead. Yeah.
So thank you for giving me this opportunity. You know, I think it's core ICT is the foundational technology for the country. This is something we need to build capability in, and if we don't do it, the implications are much wider elsewhere. And this is one area where we have a tremendous amount of skills. And lots of MNCs operate in India, and we have a service sector. All that we should grow and do more, but we have to build Indian headquartered companies too. And it's not easy. It's very, very difficult. There are lots of barriers. And the one issue that India has lacked is really a comprehensive government support. That has not been there. And only mainly because the government does not understand this industry, all the barriers it has. So, many other countries are broken in, and we can learn from them. I think it's time for us, for the government to act. And unless the government, I think, is critical for building this thing. But I'm absolutely sure that the human resources for it is there. And when India joins this ecosystem and contributes, the world will be a better place. We can bring our talent, our ideas to the broader ecosystem, and we'll be welcome. Thank you.
Thank you. Thank you very much. I think it has been absolutely fantastic. I think all of us have learned a lot from Professor Paulraj's presentation today, and question and answer sessions also. I wish we had a little more time, okay, or maybe much more time. I'm sure the way the questions are, we could have easily gone on for another hour, okay. But then at some point we have to call it a closure. Maybe we'll little later, after some more time, we can invite him again and on a slightly broader topic, maybe a year down the road, so that again there'll be some fresh things that Professor Paulraj will be able to share with us. So we are deeply indebted, and we hope that he'll keep coming, guiding us and convincing our government to do what he has been advocating in terms of really creating that ecosystem and the support system. Lastly, what I would like to mention, TSDSI is the one who has organized this. Many of you have come on board and joined this webinar. One of the objectives also is that we would like to get a larger membership for TSDSI. So please come forward. Okay, many of you are there on the currently still logged in. Please come and join TSDSI. I think it will be an exciting journey, and India can make a great contribution in the standardization of future technologies, 5G, 6G, as we go along. Thank you very much.
Thank you very much, sir. Thank you, Professor Paulraj and Professor Desai, for moderating. You have just set the context, and as we can see from the number of questions and the wide range of questions, we hope to cover some of these questions in a deeper manner in the coming up, in the webinars that will keep coming up. We intend doing this webinar series, editions of this series, once every fortnight. And I'm very happy to announce that Dr. Kumar Sivarajan, a CTO Tejas Networks and a former chairman, will be taking the next session on 6th August. He'll be covering front haul and back haul on 5G. So several questions that were asked today may get addressed there. And we will see if we can get Dr. Kumar to be with us for 1.5 hours, going by the kind of response we got to this particular webinar. So thank you very much, and hope to see you all on 6th August again. Do keep a watch on our website where we announce the events. And if you want, we can add you in a circulation list. Thank you very much. Namaste.
Okay.
Thank
Bye-bye.
you.
Thanks. Have a nice day, Paul. Okay.
Goodbye.
And if any folks want to stay back, we have and enjoy the social lounge networking opportunity. We'll keep the social lounge open for another 15 minutes for folks who want to do some kind of discussions amongst the participants. Please stay back in the social lounge, which will remain open till 7:45 p.m. Thank you.
Thank you.